Students have to be able to relate the structures of the eye to their functions, including accommodation to focus on near or distant objects and adaptation to dim light. The light-sensitive layer at the back of the eye is called the retina. The light rays have to be focused on the retina. The retina is composed of many thousands of tiny light receptor cells. Some of these are called rods and are very sensitive to low light intensities. Others are called cones and only work in bright light conditions. However, the advantage of the cones is that they can give color vision. This is because there are green, red and blue cones. The proportion of cones that are being stimulated tells the brain the color of the object. For example, if the greatest proportion of stimulated cones is blue, then the object must be reflecting blue light. Light falling on the cones and rods will cause them to generate electrical impulses. These will be passed to the brain via the optic nerve. The brain then interprets these electrical impulses, and this is how we see. Most of the eye is covered in a tough white layer called the sclera. However, at the front of the eye, the sclera is missing. In its place is a transparent bulge called the cornea. We can see this clearly when we look at somebody's eye from the side. The function of the cornea is to refract light rays coming into the eye. Looking at somebody's eye from the front, the most obvious thing is the coloured muscular disc. This is called the iris. Looking closely at the iris, we can see there are lots of tiny muscular fibres inside. These contract or relax to change the size of the hole in the centre. This is the pupil. In poor light conditions, the pupil needs to be larger to allow more entry of light into the eye. In bright light conditions, the pupil needs to be smaller, because if too much light was to enter the eye, it could damage the sensitive retina at the back of the eye. As we have already said, much of the refraction of light rays into the eye is carried out by the cornea. However, the angle of light rays from close and distant objects are different, and so different amounts of refraction are needed. The cornea cannot change the amount of refraction. For this reason, there has to be another lens, which is the lens inside the eye itself. This lens is able to change its shape and so adjust the amount of refraction taking place. This is called accommodation. Let's see what happens for accommodation of a close object. Light rays from a close object enter the eye at a wide angle. This means they will need a lot of refraction. A shorter, thicker lens will be needed. To achieve this, the ciliary muscles will contract. This will have the effect of pulling in the front of the eye. Tension will be reduced on the suspensory ligaments. They will become slack. This will take the tension off the lens, and the lens will revert to its natural, wide, bulging shape. This makes the lens a strong lens able to produce enough refraction. Let's look at accommodation of light from a distant object. Rays of light from a distant object are almost parallel. This means that they do not require much refraction. A weak lens is needed. A thin lens needs to be produced. For this to happen, the ciliary muscles will relax. As they relax, the front of the eye will widen. This will put tension on the suspensory ligaments, which will be pulled tight. The lens will be stretched out into a thin shape. It is now the correct strength to focus the light on the back of the eye. Many people suffer with a condition known as myopia, otherwise referred to as short-sightedness. This is because their eyeballs are too long. The retina is too far back. This means that when the lens is focusing on a distant object, even though the lens is as thin as it can go, it is still over refracting the rays. In other words, the rays are being focused in front of the retina, leading to a blurred image on the back of the retina. To correct this problem, we need to put a lens in front of the eye. This could be a contact lens or a spectacle lens. The type of lens required is what we call a concave lens. This will spread out the rays from the distant object, thus avoiding the problem of the lens over refracting the rays. Now the rays are focused to a sharp point at the back of the eye on the retina. Some people suffer with an eye condition called long-sightedness or hyperopia. This is normally because the eyeball is too short. This means that when the lens is refracting on a close object, despite the fact that the lens is as thick and strong as it can possibly be, it is still unable to refract the rays onto the back of the retina. The rays are effectively focused behind the retina, leaving a blurred image on the retina itself. This means that the lens needs some extra help with its refraction. To do this, we put a lens in front of the eye called a converging lens. The converging lens will do some refraction of the rays before they come into the eye. Now the lens inside the eye is able to refract those rays to a sharp point on the retina. Let's consider the options for treating short sight or long-sightedness. Many people choose to wear spectacles. Others will choose contact lenses, either hard or soft contact lenses. In either case, these fit onto the surface of the cornea. A permanent solution is laser eye surgery. This involves a laser cutting away at the surface of the cornea and changing its shape so as to correct the vision. Recently, another treatment has been developed, particularly with people with severe short-sightedness. This is where an extra lens is put inside the eye. They still have their ordinary lens, but now they have an extra lens to help with the refraction. If you look at the outside of the eye, you'll notice there are some strong muscle groups. First of all, I need to remove that muscle. So here I am removing these muscles from the outside. Now, the muscles move the eye very quickly in different directions. So here we have the eye. I've removed most of the muscle. We can now see a cord coming out the back of the eye. This is the optic nerve and carries all the impulses to the brain. You can also see what's called the sclerotic layer, which is very tough and gives the eye much of its strength. If we look at the back of the eye, we can see the optic nerve. The optic nerve carries the impulses to the brain to give you information about what you're looking at. If we look at the eye from the side, we can see a transparent bulge. This is the cornea, which does much of the refraction of light onto the back of the eye. If we look at the eye from the front, we can see the coloured iris and the dark hole in the centre, which is the pupil. The iris can change the size of the pupil to control how much light is allowed into the eye. If too much light is allowed in, it could damage the retina. If not enough light is let in, then you would have trouble seeing what you are doing. Okay, we're now going to cut the eye in half to give a front half and a rear half. To do this, I need to make an incision in the sclerotic layer. But this is best done by nipping it with a pair of scissors. Once the hole has been made, we can insert the sharp end of the scissors. And begin to cut all the way round. Notice some liquid coming out from the eye. This liquid is called the vitreous and gives the eye its shape. The eye is no longer firm, it's very floppy now. The lens has now come out of the eye. Around the lens is the ciliary body. We can now see the lens that was inside the eye. Unlike the cornea, which is a fixed focus, the lens can adjust its focus. We call this accommodation. In order for this to happen, little suspensory ligaments are needed. We can just see these as little tiny black lines around the edge of the lens. Okay, we have successfully cut all the way around the eye, so we now have two halves. Hold the front of the eye up to the light, we can see the iris, and we can see that the pupil is simply a hole in the centre of the iris. The iris can change the size of the pupil to control the amount of light that is allowed to enter the eye. We're now looking at the back of the eye. We can see the optic cord coming out the back of the eye, and we can see this black coloured surface. Black is a good choice here because black will absorb light and prevent internal reflections. Over this black surface is stretched the retina, which contains all the light-sensitive receptors, the cones and the rods. If you look carefully, you can see a little spot here. This little spot is where the optic nerve joins the retina. There will be no receptors here, so any part of the image that falls on this spot will not be detected. So we call this the blind spot.